Section 5. Files. Introduction. What is a file? A file is one document, one image, one something. In the world of computing, the terms folder and file are entirely separate, distinct, and non-interchangeable. Folders contain files. Files cannot contain folders. Files are represented by various icons that indicate which program is used to open them. Learning outcomes. At the end of this study session, you should be able to 1. Define files and state its advantages. 2. Discuss operations of files. 3. Explain file naming convention. 4. Discuss file attributes. 5. Discuss different types of files. 6. Explain file record format. Files. In computer terminology, any collection of data that is treated as a single unit on a storage medium such as a disk is referred to as a file. The purpose of a disk is to store information. This information or data is said to be stored in files. A file is also a collection of logically related records. Every program and data file accessed by computer system and every piece of computer software is treated as a file. Files contain computer records which can be documents or information which is stored in a certain way for later retrieval. To access a file, a user does not need to know its exact physical location on disk pack or storage medium. All you need to do is request for the file and the operating system fetches it for you. For a program to use a file, it needs to know the structure of the file and needs to interpret its content before it can process it. Advantages of files. A file is both an input and an output medium, and as such, it has the following advantages from different points of view. Files are used to save time for data entry and reduce its processing time. Files are used for storage and subsequent retrieval of data. Files are also used to correct the incorrect data and also update the correct form data. Files are used in texting and debugging of programs. Files are used for processing voluminous data. Using files, data can be stored on many devices like floppy disk, hard disk, flash disk, magnetic tapes, magnetic drums, etc., which help for the permanent storage and distributed data processing. Operations of files. The following are the basic operations that programs can perform on a file. Create a new file, open a file, which makes the file content available to the program. Find, read data from a file, write data to a file, retrieve, close a file, terminating the association between it and the program. Files on a computer can be created, moved, modified, grown, shrunk, and deleted. In most cases, computer programs that are executed on the computer handle these operations, but the user of a computer can also manipulate files if necessary. For instance, Microsoft Word files are normally created and modified by the Microsoft Word program in response to user commands, but the user can also move, rename, or delete these files directly by using a file manager program such as Windows Explorer or Windows computers, or by command line CLI. In Unix line systems, user space processes do not normally deal with files at all. The operating system provides a level of abstraction, which means that almost all interaction with files from user space is through hard links. Create, open, find, read, retrieve, close, write, append, store, delete, rename. File naming convention. It is important to name and organize your files in a consistent and descriptive manner so that it is obvious to you and to others where to find specific data and what each file contains. It is a good idea to set up a clear directory structure that includes the project title with a date and some type of unique identifier. Individual directories may be set up by date, researcher, experimental run, etc. File names should contain sufficient information that the precise experiment can be identified from the file name. Always use the same format for naming your files and include the same information. You can consider including in file names 1. Project or experiment name or acronym. 2. Location/spatial coordinates. 3. Researcher name/initials. 4. Date or date range of experiment. Always use the same format such as YYYY, MMDD. 5. Type of data. 6. Conditions. 7. Version number of file. A 3-letter file extension for application-specific files. Each file needs a specific file name. The file name usually has two parts, the name and the extension. The extension identifies the type of data the file contains, as well as tells the operating system which program to use and open it. Some of them are listed below. File attributes are file-specific information that is maintained by the operating system are used by the operating system to manage the file. It varies across different operating systems. Some of the attributes are visible to the user while others which are not visible to the user. The file attributes include file size, modification date, creation time, type, location, etc. The file name is the only information kept in human-readable form and easily visible to the user. Files also have an identifier, which is a unique tag number that identifies the file within the file system. The location is a pointer to file location on the storage medium. Most files also have attributes such as time, date, and user identification. That is, data used for protection, security, and usage monitoring. Let's examine the table below that lists some other attributes and what they represent or store. Attribute: protection, meaning who can access the file and in what way. Password: password needed to access the file. Creator: ID of the person who created the file. Owner: current owner. Read-only flag: 0 for read/write, 1 for read only. Hidden flag: 0 for normal, 1 for do not display in listings. System flag: 0 for normal files, 1 for system file. Archive flag: 0 for has been backed up, 1 for needs to be backed up. ASCII/binary flag: 0 for ASCII file, 1 for binary file. Random access flag: 0 for sequential access only, 1 for random access. Temporary flag: 0 for normal, 1 for delete file, on process exit. Lock flags: 0 for unlocked, non-zero for locked. Record length: number of bytes in a record. Key position: offset of the key within each record. Key length: number of bytes in the key feed. Creation time: date and time the file was created. Time of last access: date and time the file was last accessed. Time of last change: date and time the file has last changed. Current size: number of bytes in the file. Maximum size: number of bytes the file may grow to. Types of files. We can classify or group all files stored on any computer system into 3. These are program files, data files, and directories. Program files. These are files that contain instructions. The instructions tell the computer what to do. In some instances, program files are used to create data files. Examples include Microsoft Word, used to create a Word document, Windows XP, Microsoft Excel, Adobe Photoshop, CorelDRAW, Adobe Acrobat, etc. The most common extension for program files is Excel. Data files. Data files contain data or information. These types of files are the end product of a data processing cycle. Data files include files with extensions such as docs, XLS, JPEG, MPEG, text, etc. Directories. A directory is a file that briefly catalogs a set of files stored on a disk. That is, the directory contains the listings of file names and their attributes. In Windows, directories are represented as folders. Each file entry in every directory contains information describing that file. Some of these include file name, usually represented in ASCII code, file type, the organization and usage that are dependent on system, file size, the size of the file location, Identification of first physical block or all blocks where file is stored. Figure 5.3 shows a directory when viewed from a command prompt, while Figure 5.3b shows a snapshot of the same directory in Windows. See if you can spot a file in both figures. Figure 5.3a, a directory. Figure 5.3b, a directory in Windows. Some of the operations that we can carry out on directory include create, make a new directory, find list, search or enumerate directory entries, rename, change name of an entry without changing anything else about it, destroy, removes directory. Directory structure. Directories can be structured as single level, two level, or hierarchical. Try and identify which structure your computer uses. Figure 5.4 shows how the various structures are organized. The single-level directory system shown above contains 4 files owned by 3 different people, A, B, and C, while the two-level directory system has 3 user directories that contain the user's files, with the letters indicating the owners of the directories and files. With the hierarchical directory system, users are allowed to create their own directories and subdirectories. This is the structure used by Windows operating system. See Figure 5.5. File record format 4. As earlier learned, a file is a collection of logically related records. A record is a collection of logically related fields. These records can be in 2 main formats, fixed length and variable length. The file descriptor stores information about the record format, how it is blocked, and other related information. 1. Fixed length records. These are records that are of the same size in a file. In a fixed length record, both the number of fields and the length of each field are fixed. Fixed length records are the easiest to access directly and the most common type. They are ideal for data files. However, the record size is a critical issue. If it is too small, data truncation may occur, and if too large, then space is wasted. 2. Variable length records. These are records that are of different sizes in a file. In variable length records, the width of the field can be adjusted to each data occurrence. Variable length records are difficult to access directly because it is hard to calculate exactly where the record is located within the file. They are frequently used in files accessed sequentially, e.g. text files, program files, or files using index to access records. Variable length records do not leave empty storage space and do not truncate any characters. 3. Field. Fields are data items. A field is a meaningful collection of related characters. It is the smallest logical data entity that is treated as a single unit in data processing. Summary. In study session 5, you have learned that 1. In computer terminology, any collection of data that is treated as a single unit on a storage medium, such as a disk, is referred to as a file. The purpose of a disk is to store information. This information or data is said to be stored in files. 2. Files on a computer can be created, moved, modified, grown, shrunk, and deleted. In most cases, computer programs that are executed on the computer handle these operations, but the user of a computer can also manipulate files if necessary. 3. It is important to name and organize your files in a consistent and descriptive manner so that it is obvious to you and to others where to find specific data and what each file contains. 4. File attributes are file-specific information that is maintained by the operating system and are used by the operating system to manage the file. It varies across different operating systems. Some of the attributes are visible to the user, while others which are not visible to the user. 5. All the files stored on any computer system can be classified or grouped into 3. These are program files, data files, and directories. 6. A record is a collection of logically related fields. These records can be in 2 main formats, fixed length and variable length. The file descriptor stores information about the record format, how it is blocked, and other related information. This is the end of study section 5. Thanks for listening.